Out of the Cave to Become Men, Journaling History by Doug Ferguson, read by Doug Ferguson, Chapter 8.2.3. In the beginning, the narratives, modern narrative, Panspermia. Did the Earth spawn from proto-life in comets and asteroids that have a common orbital path as the Earth? Is it possible that before the Theia impact, the Earth was already becoming a factory, creating proto-life? What conditions were happening on the Earth then? Some say that before this impact, the Earth had an atmosphere which was a thick chemical stew. That at this early stage of the solar system, the sun was not generating the heat that it does now, and that this thick stew of an atmosphere would be absorbing solar energy at a rate much greater than the current atmosphere. Could this environment have created proto-life of simple amino acids? Could the next stage of life have been prepared by the Theia impact? In 2004 Stardust mission, it was verified that the comet Wild 2 carried amino acids. In a later mission by NASA's Deep Impact spacecraft, the craft was purposely crashed into Comet Tempel 1 in 2005, and the dispersed cloud from the impact released a mixture of organic and clay particles, which was discovered to reside inside the comet. It was then theorized that life could have used clay particles as a catalyst to help give structure for the arrangement of simple organic molecules. Some began to conceive hypotheses about how these simple organic molecules in clay might have transformed on the Earth into more complex structures. This I find kind of curious, for in Genesis, the process for the creation of men and for life in general was for God to breathe life into formed clay. How and why would these writers of Genesis derive this concept of life being held together by clay? Is there any symmetry between these different narratives? Japanese scientists have considered the possibilities that comets have amino acids and that the energy created from the impact helped create short peptides up to 3 units long, tripeptides. They developed a hypothesis and created an experiment to test the possibilities, which is highly commendable. To test the theory, an impact was used to create a catalyst by the process of condensation to create the formation of di- and tripeptides using a silicate support structure. You say tomato, I say tomato. You say silicate, I say clay. In experiments conducted by Dr. Haruna Sugahara from the Japan Agency for Marine Earth Science and Technology in Yokohama, and Dr. Koichi Nimura from Nagoya University, they created an environment which might stimulate the conditions at that time early in Earth's past. According to their paper, in experiments, the frozen amino acid mixture was sealed into a capsule and shot from a vertical propellant gun, which was used to simulate impact shock. The frozen mixture in the capsule was composed of amino acid, water, and silicate at cryogenic conditions of 77 degrees Kelvin. Kelvin is a primary unit of temperature measurement in physical sciences, but is often used in conjunction with Celsius degree, which has the same magnitude. The definition implies that absolute zero Kelvin is equivalent to minus 273.15 degrees centigrade, or minus 459.67 degrees Fahrenheit. In the experiment, the scientists analyzed the post-impact site with gas chromatography, and they found tripeptides. To create these tripeptides, the condensation process of bonding amino acids together occurred. When a condensation process occurs, water is released along with some energy. Using observation, logic, and reasoning, they've developed their hypothesis. Their observations of the space missions gave them an opportunity to develop some logical assumptions that space objects could impact the Earth and create some sort of proto-life. I wonder what they will consider next in their scientific inquiries. Will they be Dr. Frankenstein? Will they be creating life? It's a lie. It's alive! This finding indicates that comet impacts almost certainly played an important role in delivering the seeds of life to the early Earth, said Sugihara. It also opens the likelihood that we will have seen similar chemical evolutions in other extraterrestrial bodies, starting with cometary-derived peptides. These conclusions he made are based on the assumption that by some type of process in the forming of the comets in space, amino acids are created in silicate casings. Though they have not proposed the process which creates amino acids in comets, I propose that the Earth these panspermia comets by the Theia impact. Because of the specific nature of these comets, not all comets would have had this type of composition, but only comets that tended to have the orbit that intersected that orbit of Earth. If the Earth created these amino acids, which were encapsulated in silicon and clay during the Theia impact, then they would set out on their orbits to receive the Earth when things calmed down on its surface. The news from the Rosetta mission to Comet 67P Churyumov-Gerasimenko also indicates that comets are rich in sources of materials, and more discoveries are likely to be forthcoming from that mission. Two parts of this story are how complex molecules are initially generated on comets and then how they evolve when the comets hit a planet like Earth, said Professor Mark Burchell from the University of Kent in the UK, who was commenting on the new research from Japan. Both of these steps can involve shocks which deliver energy to the icy body. Building on earlier work, Dr. Sugihara and Dr. Miyamura have shown how amino acids on icy bodies can be turned into short peptide sequences, another key step along the path to life. Comet impacts are normally associated with mass extinctions on Earth, but this work shows that they probably helped kickstart the whole process of life in the first place, said Sugihara. The production of short peptides is a key step in the chemical evolution of complex molecules. Once the process is kick-started, then much less energy is needed to make longer-chain peptides in terrestrial aquatic environments. Scientists also indicate that similar bootstrapping could have happened in other places in our solar system, such as on the icy moons Europa and Enceladus, as they likely underwent a similar comet bombardment. Nancy Atkinson, currently University Today's contributor editor, and others are hopeful that this process, presented by the Japanese scientists, could have spawned life on Earth, and by projection could also be spawning life on other moons in the solar system and on other worlds in the universe, as she has presented in her article, The Earth Being Seeded Proto-Life by Comets and Asteroids. The idea of panspermia, that life on Earth originated from comets or asteroids bombarding our planet, is not new, but new research may have given the theory a boost. Scientists from Japan say their experiments show that early comet impacts could have caused amino acids to change into peptides, becoming the first building blocks of life. Not only would this help explain the genesis of life on Earth, but it could also have implications for life on other worlds. But with my hypothesis, other star systems would need an early Earth-like planet going through similar processes to create amino acids in clay substrates. Then another celestial body would have to impact it to create the next stage of planetary evolution. Then the impact would form comets to seed proto-life back on the surface through the process of panspermia. Scientists state that comets seeded the Earth with protolife. Where did this protolife come from? It is thought that it could have occurred by violent heating of comets as they passed close to the Sun. There would be many variables to be considered for interpreting the data accurately. What type of process would be necessary to produce such a result? To test this theory, each pass around the Sun should increase the density of amino acids in a comet. So a sample of the comet would have to be taken before and after a trip around the Sun to count the density of amino acids. If the process could be created in the laboratory with the same environment as what would occur in a comet as it orbits the Sun, maybe this theory could hold some weight. What is needed to produce this result? I think that many scientists want to romanticize about the possibilities that life could easily occur anywhere in the universe, so they blithely come up with the theory that the process of comets moving around the Sun creates amino acids. But one should be open to all possibilities and not be too dogmatic in considering other ideas. I propose another speculative theory that the Earth created amino acids in the pre-impact chemical stew of Earth. The Theia impact then spewed out into space amino acids embedded in clay substrate. Finally, these debris would reseed the Earth with proto-life. And as the Japanese scientists demonstrated, the reseeding process created tripeptides to help the next stage in the formation of life to occur on Earth. Some things to consider by my theory is that not all asteroids and comets were formed by the Theia impact, so many comets would not have amino acids in them because they would not be leftovers from the Theia impact. For this subject on only how the amino acids came into embedded in the comets, there are so many questions, and there is not enough real data or theories presented to challenge. At this point, all that can be done is to speculate about the process which created amino acids on comets. About 3.5 billion years ago, there is recorded evidence of biological activity in the earliest known fossils on Earth. But at that time, scientists conjectured that the early Earth had little water and carbon-based molecules on the surface. This could be because, as I mentioned before, the Earth had just become molten from the Theia impact, so water on the surface would be vaporized into gas and blown away, and all amino acids would be broken down into simple molecular structures. So how could these building blocks of life be delivered to the Earth's surface so quickly? To sum up the hypothesis presented by Panspermia, when the Moon was formed by the Theia impact, the molten Earth carbonized the amino acids on the Earth. The impact ejected enormous amounts of material into space, some of the material being amino acids embedded in clay. It makes sense that much of the impact material continued to orbit in similar paths as the Earth and caused the time of the late heavy bombardment. These collisions of comets and asteroids boomeranged with the Earth, resupplying it with abundance of water and carbon-based molecules. When these ejected comets with amino acid returned to splatter the Earth, the process of panspermia would produce the bootstrapping needed to start the process towards life. Also, scientists have other proposals that they are exploring. Some using conjectures theorize that once things cool down, normal terrestrial processes such as lightning storms or hydration and dehydration would continue the process of creating peptides into more complex forms to bring life to the planet, though no one knows the process or why this process should occur. As with much about the universe and everything, there are plenty of questions to search answers for. The joy of the journey is in exploring. That concludes Panspermia. The next topic to be discussed are tectonic plates.